Our today's topic is Bohr's theory of hydrogen atom. So many scientists have given so many theories to explain the atomic structure and electronic arrangement, so on. Now just we'll look at stability of atom. We know that elements consists of atoms. Electrons revolve around the nucleus, that means which is positive charged, and nucleus also consists of protons and neutrons. Many scientists like Thomson and Rutherford gave several theories about the atomic structure and stability of atom, but these theories could not explain the stability of atom completely. To overcome this instability, Bohr has proposed that electron revolving in an orbit does not radiate energy and its angular momentum is quantized, so the orbit will be stationary and stable. Bohr successfully explained the stability of hydrogen and its line spectra. Now we'll go to Bohr's theory of hydrogen atom. We know the electrons revolves around the positive nucleus with velocity v under the Coulomb's attractive force, that is E square by 4 pi epsilon naught r square, where r is the radius of the orbit, and the centrifugal force is balanced by this electrostatic force of attraction. That first postulate is an electron in an atom moves in circular orbit about the nucleus under the influence of Coulomb's force of attraction between the electron and the nucleus. As the atom is stable, the Coulomb's force of attraction is balanced by centrifugal force, that is E square by 4 pi epsilon naught r square is equal to mv square by r. The second postulate is that only those orbits are possible for which the orbital angular momentum of the electron is equal to an integral multiple of h by 2 pi. That means angular momentum is quantized. Where h is Planck's constant. Bohr's third postulate is the electron revolving in such stationary orbits does not radiate electromagnetic radiation. The total energy of the electron remains constant. The electromagnetic radiations are emitted if an electron jumps from one stationary orbit to another stationary orbit, that is from E2 to E1. Therefore, the energy emitted is equal to the energy difference of these two levels, that is, you can write E2 minus E1 is equal to h nu. The radius of the orbits can be found out by using equation 2. So from equation 2, the radius can be solved, that is, we can write the value for v is equal to nh by 2 pi mr from equation 2, and substituting that in equation 1, you will get E square by 4 pi epsilon naught r square is equal to m by r nh by 2 pi mr square. So solving this, we will get radius of the orbit as n square h square epsilon naught by pi m e square. Where n is principal quantum number. Example, you can say radius of the first orbit as r1. Substituting all the constant values, you will get as 0.529 into 10 to the power of minus 10 meter. Or that you can say as 5.5 to 9 angstrom units. You can also find out the velocity of electron velocity of revolving electron substituting r from equation 4 in equation 2, we can write mv into r value, that is n square h square epsilon naught by pi m e square is equal to nh by 2 pi. Then you will get v is equal to e square by 2 nh epsilon naught. As v is inversely proportional to n, the velocity of innermost orbit has highest velocity. The other term about the motion of this electron is orbital frequency. That is defined as nu is equal to 1 by t, where t is the time period, that is equal to velocity by 2 pi r. Substituting the values of v and r in this equation, you can get this frequency as m e to the power of 4 by 4 epsilon naught square n cube h cube. Then the time period also can be calculated by taking reciprocal of this frequency, and you can write that value as 4 epsilon naught square n cube h cube by m e to the power of 4. The total energy of the electron also can be calculated, that is electron energy it consists of two types, one is kinetic energy, another is potential energy. Therefore total energy can be written as kinetic energy plus potential energy. Kinetic energy generally defined as half mv square. Substituting the value of v in this equation, we can get kinetic energy, that is m e to the power of 4 by 4 n square h square epsilon naught square. And the potential energy equation, we know that minus m e to the power of 4 by 8 n square h square epsilon naught square. This can be obtained from the work done by unit charge at a point r distance from the center of the nucleus. So substituting in this equation that Coulomb's attractive force and distance r, we can get potential energy. So total energy can be obtained by adding both kinetic energy and potential energy. Taking the values in this equation, can write that m e to the power of 4 by 4 n square h square epsilon naught square minus m e to the power of 4 by 8 n square h square epsilon naught square. The final value is minus m e to the power of 4 by 8 n square h square epsilon naught square. This is the total energy. As it is depend on n, you can write this as en also. Now we can calculate the frequency of radiation, that is h nu. We have taken that as difference between the two energy levels En2 minus En1. From equation 7 we can get En2 by taking n is equal to N2, and we can get En1 by taking n is equal to N1, and we can get the value for frequency of radiation emitted by that h nu is equal to, you can write as m e to the power of 4 by 8 h square epsilon naught square into 1 by n1 square minus 1 by n2 square. Taking frequency is equal to c by lambda. In this equation we can get the wavelength, that is nu is equal to c by lambda is equal to m e to the power of 4 by 8 n square h cube not actually, this is not n square, h cube, that is epsilon naught square, into, as we have already taken this, what is 1 by n1 square minus 1 by n2 square. Then the lambda or this nu bar can be obtained from the equation m e to the power of 4 by 8 c h cube epsilon naught square 1 by n1 square minus 1 by n2 square. This is the equation for either wave number, or you can also find out the wavelength of the spectral line or radiation emitted from the hydrogen atom.